evpn failures are difficult when engineers start at the symptom and sample unrelated commands. The system has a dependency order: intent, session and family, root and policy, next hop resolution, forwarding realization, and packet behavior. The rejected assumption is that more output creates more certainty. It does not. The core learning is this: State 1, expected packet walk, inspect evidence in dependency order, and stop at the first layer where the expected object disappears or an unexpected object appears. That boundary identifies the owner and prevents changes to healthy layers. Here is our agenda. We shall freeze the intended service and one representative packet. We shall verify BGP transport and the evpn address family. We shall inspect the exact route, attributes, selection, and route target policy. We shall resolve the VTEP and any overlay index dependency. We shall cross into software and hardware forwarding objects. Then, we shall place packet captures around each transformation. Finally, we shall turn symptoms into a decision tree and preserve a reusable evidence bundle. The objective is fast fault isolation with minimal mutation, not a catalog of show commands. Begin with one packet, name its source interface and VRF, destination MAC or IP, local bridge or route lookup, inner rewrite, VNI, outer source and destination VTEPs, remote decapsulation context, remote lookup, and egress. Include MTU and expected CMP entropy when relevant. This prediction tells you which route and forwarding objects should exist. It also identifies capture points. Without it, an engineer may find a healthy route for another tenant or inspect the wrong VNI and mistake data volume for evidence. Freeze the packet walk before making any configuration change. The first gate is configuration intent. Confirm the access VLAN or routed interface, bridge domain, tenant VRF, L2 and L3 VNIs, RD, import and export RTs, Anycast gateway, and local VTEP source. Compare the running state with the authoritative rendered and persisted configuration. A single wrong RT or VNI can make all later protocol output internally consistent but irrelevant to the intended tenant. Check both ends and any route reflector or border policy. If intent differs, repair the owner of configuration. Do not compensate with a downstream static route or forwarding entry. At the control plane transport gate, verify the BGP session, then the L2 VPN evpn family specifically. Confirm capability negotiation, neighbor activation, expected prefixes or routes received, and route reflector propagation. Check reset reasons, maximum prefix state, and policy counters. If the family is absent, no amount of VXLAN or FDB inspection will create remote evpn reachability. If the route reflector sees the route but a client does not, examine reflection and export. If the client receives it but does not import it, move to the policy gate. Keep session health and service health as separate facts. select the exact route required by the packet walk. For Type 2, match MAC, optional IP, Ethernet tag, RD, ESI, VNI fields, RTs, mobility sequence, and next hop. For Type 5, match prefix, gateway or ESI overlay index, routers MAC, RT, and next hop. For Type 3, match service and origin. Trace origin, reflection, receipt, import, and selection. A route count cannot reveal a wrong RT or stale mobility sequence. If received but not imported, policy owns the failure. If imported but not selected, explain the competing path. An evpn path may depend on more than its BGP next hop. A Type 5 prefix can use a gateway IP or ESI overlay index that resolves through Type 2 or Type 1 state. A multi-homed MAC may depend on EAD routes for alias paths. Every remote object ultimately depends on underlay reachability to one or more VTEPs. Verify recursive resolution, ECMP next hops, source loopback, MTU, and ARP or ND on the underlay adjacency. Withdraw the resolver mentally. The dependent route should become unusable. If the tunnel endpoint is unresolved, stop. The forwarding pipeline cannot repair it. Now inspect realization. A bridged packet needs the correct MACVRF, FDB disposition, VXLAN tunnel, and BUM list when the destination is unknown. A routed packet needs the correct IPVRF route, next hop group, neighbor, or router's MAC, and L3 VNI. A multi-homed path needs eligible segment members and DF or split horizon filtering. Compare software, kernel, or platform database and hardware state. If software has the object but hardware does not, the platform pipeline owns the fault. If both have it, verify counters and proceed to packets. Place captures at access ingress, local underlay egress, remote underlay ingress, and remote access egress. At ingress, verify the original frame or packet and VLAN. On the tunnel, decode outer MACs and IPs, UDP port, VNI, inner MACs, inner IP, and hop limit changes. At decapsulation, verify the selected VRF or bridge context. At egress, verify the final rewrite. For BUM, count copies and destinations. Use a distinctive payload and fixed 5-tuple and synchronize clocks. A packet absent at the first point is not an evpn fault. Most incidents fit one of three first divergences. If the exact route is absent, investigate origin, family, reflection, or policy. If the route is present, but the forwarding object is absent, investigate resolution, interface topology, translation, orchestration, and resource limits. If route and forwarding state are present, but the packet fails, inspect encapsulation, MTU, ECMP path, access membership, filters, hardware counters, and the remote lookup. This classification prevents random configuration changes. Record why every earlier gate passed, and hand the case to the owner of the first failed gate with the correlation key and timestamp. A successful broadcast does not prove known unicast forwarding, and successful unicast does not prove BUM replication. Unknown unicast, broadcast, and multicast may share or differ in replication policy. Type 3. Membership and a PMSI attribute build the flood set, while a Type 2 root and FDB entry drive, known unicast. DF and split horizon filters apply to multi-homed BUM egress. Test ARP or ND, known unicast after learning, forced unknown unicast, and multicast separately. Count copies and confirm that no frame returns to the originating Ethernet segment. Negative evidence is deliberate absence at a named layer. For isolation, show the root may exist globally, but is absent from the forbidden VRF, hardware table, and packet capture. For failure, show the dead VTEP has left every next hop and replication group and receives no counter increments. For multi-homing, show exactly one DF-governed copy and no return to the same segment. An application timeout is weak because DNS, firewall, MTU, or remote host failure can produce the same symptom. Strong negative proof identifies the precise object that must not exist and the capture point where no packet must appear. Before changing configuration, capture the topology and intent revision, device image and component versions, synchronized timestamps, session and family state, exact routes and policy, next hop resolution, software and hardware objects, counters, and packets. Record the command and platform version with every output. If a change is required, state the hypothesis, expected evidence change, rollback, and observed result. This bundle enables peer review and regression testing. It also prevents a resolved incident from becoming folklore. Sanitize tenant payloads and secrets, but preserve root keys, headers, timing, and object relationships needed to reproduce the reasoning. Use the tree as a sequence of falsifiable questions. Is the representative packet generated? Does running intent map it to the expected service? Is the exact evpn route present and imported? Are every overlay and underlay dependency resolved? Is the required forwarding object present in software and hardware? At which capture point does the packet first disappear or change incorrectly? Each answer narrows the fault domain. Resist the urge to restart processes or add static state before the boundary is known. Those actions destroy evidence and can mask the owner. A good troubleshooting method makes the candidate set smaller after every command. The core learning is this: troubleshoot evpn and VXLAN in dependency order and stop at the first layer where expected evidence disappears. Freeze one packet walk. Verify intent, BGP session, and evpn family, the exact route and import policy, every overlay and underlay resolver, the software and hardware forwarding object, and captures around each transformation. Treat BUM, unicast, routing, multi-homing, and negative isolation as distinct tests. Preserve evidence before mutation. This method does not eliminate complex faults. It turns them into one bounded ownership question and prevents a healthy layer from being changed to compensate for a broken one.